Well, now our topic is work energy equation. And for solving a question under this topic, I have chosen the paper 9709/41 for the session May June 25. And we are going to solve question number 6. Let's read what question number 6 says. Two particles P and Q of masses zero point 0.3 kg and zero point 0.6 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth pulley fixed at a point B, where the inclined planes AB and BC meet. P lies the smooth plane AB, so plane AB is smooth, which is inclined at an angle theta degree to the horizontal, where sin theta is zero point 0.4. Q lies on the plane BC, which is inclined at 30 degree to the horizontal. The string is taut and the particles can move on line of greatest slope of the two planes. The particles are released from rest. And actually we are not going to solve question number A. Question number A is about tension and acceleration, which has already been solved. So let's move on to question number B. Question number B says, it is given instead that the plane BC is rough. The work done against the frictional force when Q moves 2 meter down the plane is 1.8 joule. You should assume that P doesn't reach the pulley and Q doesn't reach C. Use an energy method. They prescribed us to apply the concept of energy equation and to find the speed of Q when it has moved 2 meter down the plane. So what is the scenario? Let us see. When Q moves down, if Q slides down the slope of plane, then P will move up. So the components of work energy equation, we know the components of work energy equation are height as well as velocity. So velocity is to be obtained. So let us find the height. We can assume that these two are the systems for P and Q. So when Q was moving down, Q was moving down, P moved up. Okay. And what was the distance of their movement? It was 2 meters. So this is 2 meters and this is also 2 meters. Then if we find the height of P traveled by P is height of P is going to be 2 sine theta. Okay. So sine theta is already given in the question. Sine theta is zero point 0.4. Okay. So it is going to be 0.8 meter for P. And for Q, height of Q is 2 sine 30 degree. Sine 30 degree. 30 degree. That means it is sine 30 means half. So if we divide, if we multiply 2 by half, it is 1. 2 into zero point 0.5 meter, that means 1 meter. So the height, the final height of particle P was 0.8 meter upward, and for Q height was 1 meter down, less than the initial height. So we are going to apply the concept of work energy equation as we have been suggested. Well, so let us write the work energy equation. Work energy equation is work done by driving force minus work done by resistance force is equal to change in GPE, gravitational potential energy, plus change in kinetic energy. Now, as the particle has been released, so there is no driving force at all acting on that. There is no external driving force. Now, work done by resistance to motion is given. It is 1.8 joule. So let us write 1.8. Now, change in GP, as there are two particles connected, so we will have to write them individually. And the formula for change in GPE is mgh of P plus mgh of Q. Then change in kinetic energy is equal to half m v square, half m v square. So let me write just below this, plus half m v square of which particle? Particle P. At the same time, half m v square, half m v square of particle Q. So there will be two components for both GPE and kinetic energy. As there are two particles, so we will have to write the change in GPE of each of the particles, at the same time change in kinetic energy of each of the particles, because there are two particles. Please don't get confused with this. Then minus 1.8 is equal to mass of particle P is, if we go back to this page, it is 0.3, and mass of particle Q is 0.6. So let us write 0.3 into acceleration due to gravity is 10, and height, we have already written the height of particle P, and we have learned the direction. Actually, height means the difference between the final and initial height. Look at this, P was moving up, so the height of final height of particle P is going to be positive, and it was zero point 0.8 meters. So let us write 0.8 plus mass of particle Q, which is, it should not be plus in between them, it will be minus. Let me explain why it should be minus. So mass of particle Q is 0.6. 0.6, acceleration due to gravity is 10, and height, that means difference between the initial and final height. If you look at this figure, initial height was more and final height was less, so surely it is negative. That means Q was moving downward. Whenever a particle moves downward, then height gets decreased. That's why this is negative. And we always write the difference between the height. So difference between the height of Q was 1 meter. Okay, that means initial height was 1 meter taller and final height is 1 meter less. That's why this is negative. Remember, if particle moves down, then the direction will be negative. It is 1 plus half of m of mass of particle P is 0.3, and final velocity is to be obtained. Initial velocity was 0 because the particle was released from rest, plus, so is the second one, half mass of particle Q is zero point 0.6 kg, and final velocity of each of the particle is same, so it is simply v square. After that, if we keep on simplifying, it is going to be negative 1.8 is equal to, here if we do multiplication, it is going to be 2.4. 3 8 24, so it is 2.4. 2.4 minus, if we calculate this, it is going to be 6, plus, that is 1.5 v square plus 0.3 v square. So total it is 0.45, 0.15 and zero point 0.3, that is 0.45 v square. Then if we isolate our v square, it is going to be 0.45 v square is equal to 0.45 v square is equal to 3.6 minus 1.8, so it is 1.8, or v is equal to, we are supposed to find velocity, v is equal to 1.8 over 0.45. Hence our velocity is going to be, hence our velocity is going to be 2 meter per second, and that is our final answer to this part of the question. Let it be the last of all steps. So here hence symbol. So this is one of the simplest solutions to such concept, that means work energy equation. Let's see the next question. So remember, work energy equation works on difference between the initial and final heights, as well as difference between the final and initial velocities. These are the two components. That's why always we will have to get these two components prepared before we start our solution. And here velocity has been obtained, so there is no necessity of provision of velocity, but height must be obtained. Height is one of the components, and if we find that any particular object moves down, then height will be negative because final height gets decreased. Let's see the next question. The next question has been extracted from paper 9709/42 for the session May June 25, and we are solving question number 7. Let's read question number 7. It says a particle of P, a particle P of mass 3 kg is projected with a speed of 8 meter per second up a line of greatest slope of a rough plane inclined at 30 degree to the horizontal. P is projected from a point A on the plane and comes to instantaneous rest at a point B on the plane. P then slides back down the plane. The coefficient of friction between P and the plane is square root over 3 over 12. Using an energy method throughout, find the speed of P at the instant. At the instant it returns to A. That means, look, here they have prescribed us to follow work energy equation for whole of the solution. That means it is not a one step solution, there will be at least two steps. So in every step we will have to follow work energy equation. So this is the diagram we can sketch. As the first of all, we know the components of work energy equation is, components of work energy equations are difference between the final and initial heights, as well as difference between the final and initial velocities. Before that, we will have to find something else, which is, look at this, the plane is rough. Here it is given the frictional coefficient is square root over 3 over 12. That means the plane is rough. Whenever the plane is rough, we will have to find the normal reaction force. So let us see normal reaction force. R is equal to, as there is no upward force, it was projected just on the plane, R plus 0, and downward force is actually weight. Okay, so weight is mg cos angle is 30 degree, mg cos 30 degree, and equal to, it is going to be 3, that means 0.3 The mass of the particle is 3. So 3 into 10 is 30, and cos 30 is actually square root over 3 over 2. Square root over 3 over 2 over 2. So finally our normal reaction is what? 15 square root over 3. 15 square root over 3. Then we should know the final and initial height of the particle. So as it is moving up, so from this diagram we can see that the particle was projected from A and it reached B. Okay, so our height is going to be h is equal to AB sine 30 degrees, sine 30 degree. That means our height is going to be sine 30 is half. That means AB over 2 is the height. That means final height of the particle P. Now we can start our solution. The concept is work done by driving force minus work done by resistance to motion is equal to change in GPE plus change in KE. Since the particle was projected, that means there is no external force acting on this. So driving force was 0, work was also 0. Then work done by resistance to motion. First of all, we'll have to find the frictional force. So frictional force is actually mu r, and for work is actually AB. Okay, that means it is force into displacement. Displacement is AB. We have already found that if the particle starting from this point, particle reached until B. So the displacement traveled by the particle was AB, and work done by resistance force is equal to force into displacement. Force is frictional force, which is mu r, and displacement is AB. Then change in GPE is mgh plus change in kinetic energy is half mv squared. Then if we keep on solving more, we will get r minus mu. The value of mu is already, it is written over here. Mu is square root over 3 over 12. This one is mu is the frictional coefficient. Okay, so if we substitute the values, mu is square root over 3 over 12, and r, we have just found r was normal reaction was 15 square root over 3. 15 square root over 3 into AB equal to mass of the particle. Mass of the particle is 3 kg. Acceleration due to gravity is 10, and particle was moving up, so it must be positive. And difference between the initial and final height we have already obtained, which is AB over 2. AB over 2. Then plus half means 0.5. 0.5. Mass of particle is 3 kg, and then V square is to be obtained. V square. Okay. On the left side, if we simplify, it is going to be negative 15 3 45. 45 AB over 12 over 12. On the right side, it is going to be 30 minutes. That means 30 AB over 2. Initial velocity of the particle was given. Look at this. It was projected at the speed of 8 meter per second, and finally when the particle reached at B, it came to rest surely. Then it came back again. So at B, the velocity was 0. Initial velocity was 8. So we can substitute that. Remember, it is v square means the difference between the initial and final velocity. So final velocity is 0 and initial velocity was 8 squared. Then if we simplify, it is going to be plus 0.5 into 3, that is 64. Okay, so 64, it must be negative, it is no more positive. So 64 half is 32. 32 threes are 96, it is 96. Actually we are trying to find the displacement of AB. Okay, then if we find AB, then we will come to know exact height. So if we write both the ABs on the left side, it is negative 45 AB minus 30 AB over 2, 30 AB over 2 is equal to negative 96. Dissolving the negative symbol from every side, we can write here, this is 12. So 45 plus, there is 63, 180. So it is 45 plus 180, it is going to be negative 225 AB over 12 over 12 equal to negative 96. Hence our AB is going to be, if we simplify more, our AB is going to be 12 into 96 over 225, which is 5.12. 5.12 meters. Well, whenever we get the distance of AB, now easily we can find our final height. So final height is going to be AB over 2, 5.12 divided by 2. That means 2.56. Hence our height is 2.56. That means final height. Initial height was 0. Well, then easily we can find the velocity. They have told us to find the velocity. Let's have a look at the question. Use an energy method. Throughout, find the speed of P at the instant it returns to A. That means after reaching B, then it came back to A. So we will have to find the displacement, I mean velocity at A when it reaches A. And whenever it starts coming downward, then initial velocity was 0, surely 0, because it was projected. There is no external force acting on this. So after projection, it reached to its highest culmination and it came to instantaneous rest. So at B, it is first we have applied the concept of energy equation when the particle was moving up to B. Then we will find the particle when the particle reaches A, what was the velocity? And initial velocity was 0 because it started from rest. So let's apply the concept once again, and for that I will have to find, and look at this. Don't forget that our final velocity, I mean height, initial height was 2.56. As it is moving downward, so now height is going to be negative. Let me find some space. So the second part is when P slides down from B. The concept is same. Work done by driving force minus work done by resistance to motion is equal to change in GPE plus change in kinetic energy. So there is no, again there is no driving force because the particle was sliding down itself. So drive work done by driving force is 0, minus work done by resistance to motion is simply, it was frictional force into displacement. Displacement was AB and we have already found the value of AB is 5.12. We have already seen that the value of AB, that means displacement was 5 point AB. So we can substitute this value 5.12. 5.12, 5.12 is equal to, change in GP is mgh plus half mv squared. That means final velocity minus initial velocity, or minus mu r is, mu was zero point 0.4, we have applied already over here. We can directly write this, it was 45. Look, negative 45 over 12, then AB. So simply we can substitute this, negative 45 into AB was 5.2 over 12, equal to, mass of particle P was 3 kg. So 3 into G is H. But as I have told, at this time particle is moving downward. If particle moves down, final height is getting decreased. So it will be negative. Negative 30 into 30, and we have already decided our height was 2.56 meter. This is the height we have found, that AB over 2, it is 2.56. So we will have to just multiply by 2.56, 2.56 plus half mv square. So half, mass of particle P was 3 and V square is to be obtained, because initial velocity was 0, final velocity is to be obtained because it was started moving down from rest. So it is simply V square minus 0, that means V square. Or if we simplify more, it is going to be, so if we simplify the digital values, it is going to be negative 96. Negative 96 is equal to, it is 1.5 v square, 1.5 v squared. Okay. Hence our v is going to be, v is going to be, sorry, I made a mistake. It should be actually 57.6 and positive. Then on the right side it is zero point 0.5 v square. So finally our v is going to be square root over 57.6 over zero point 0.5. So if we divide 57.6 by 1.5, square root of that is going to be, if we round it up to three significant figures, it is going to be 6 point, let me write just beside below this, equal to 6.20 meter per second is the velocity of particle AP when it comes back to A again. So that's all about the solution to this question. Let's see the next question. The next question has been selected from paper 9709/43 for the session May June 25, and we are going to solve question number 6, which says, the diagram shows the vertical cross section ABC of a rough water slide. The section AB is a straight line of length 5 meter inclined at an angle of theta to the horizontal, where sin theta is 0.8. The point B is 2.5 meter above the level of C. A man of mass 80 kg, modeled as a particle, slides down the water slide starting from rest at A. The coefficient of friction between the man and the straight section of the water slide is zero point 0.1. Find the speed of the man at B. Actually, question number A doesn't belong to our today's topic. So we are going to solve question number B. Let's see what B says. B says, it is given that there is no change in the speed of the man when passing through B, and that his speed at c is 11 meter per second. That means when he reached the ground, the velocity was 11 meter per second. Find the work done against the resistance force as the man moves from B to C. So before we start the main solution, we should know some of the values, because as we are skipping A has been done in another topic. As we are skipping A, so we should extract some information from solution A. So let us write from A, what did we get? Initial velocity of the person, because the components of work and energy equation, we know that the components are initial and final, difference between initial and final velocity, as well as difference between final and initial heights. So initial velocity is required to be known. Let us write initial velocity initial velocity initial velocity was square root over 74, and height, the final or initial height, look at this, the height we are talking about the lower part of the slide, this portion. Okay, for this portion the initial height is 2.5 meter, final height is 0. So our height is, these are the information we can extract from solution number A. When the person started from B, his velocity was square root over 74 meter per second, and initially he was 2 meter 2.5 meter high. So let us start writing our solution. The work done by driving force minus work done by resistance to motion is equal to change in GPE as well as change in kinetic energy, gravitational potential energy as well as kinetic energy. And driving force, actually the person was sliding, as there is no other external pulling or pushing force. That's why driving force is 0, and work done for driving force is also 0, and work done by resistance to motion is to be obtained. So let it remain unchanged. Work done by resistance force is equal to, now change in GPE, you know, that is mgh plus half of mv square, or work done against resistance to motion is equal to mass of particle. I mean the person was 80 and his acceleration due to gravity was 10, and height is negative, as we have learned. He was actually sliding downward. So height is negative, that is here there will be negative symbol, and height was 2.5 meter initial height. Remember, height means the difference between final and initial height. In final height is 0, that's why it is negative, and plus half of point 0.5. A mass of particle is mass of the person is 80, and v final velocity was 0, initial velocity was 11. So sorry, initial velocity was square root over 74, final velocity was 11. So that is 11 square minus 11 squared minus square root over 74 squared. Okay, remember, velocity v square means final velocity square minus initial velocity square. So v square doesn't mean that any of the v square as well as height, these are actually a difference between the final and initial height. Well, then work done by resistance to motion is, if we multiply, it is going to be negative 800, that is negative 2000, negative 2000, and plus it is going to be final velocity 121 minus 74. So 121 minus 74, it is 1880 joule. Hence, our work done by resistance to motion is going to be, if we subtract 1880 from 2000, it is 120 joule. 120 joule is the work done against the resistance to motion. So that's all about the solution to this part. And if you get confused with negative symbol, look at this here. Height, the person was higher, at higher place initially, he was moving downward, so height will be negative, final height is 0 over here. And velocity, initial velocity at this point, this is initial velocity was square root over 74. That's why we have utilized those information. The next question has been chosen from paper 9709/45 for the session May June 25, and we are going to solve question number 1. It says a box of mass 25 kg is pulled 12 meter up a rough plane inclined at an angle of 8 degree to the horizontal. The box moves up a line of greatest slope against a frictional force of 50 Newton. The force pulling the box is parallel to the line of greatest slope. The box starts from rest and has speed 2.4 meter per second at the end of 12 meter. Find the work done by the pulling force. So the we know the components of work energy equation is difference between the final and initial heights as well as the difference between the velocities. Velocities are available, but height is to be obtained. So let us find the height. So the plane is inclined at an angle of 8 degree and the box made a displacement of 12 meter. So our height is, final height is going to be 12 sine 8 degree. Okay, so this is our height. Now let's start writing our solution. Work done by driving force minus work done by resistance to motion is equal to change in GPE as well as change in KE. So work done in favor of driving force is to be obtained. So let it remain unchanged. Work done by driving force minus work done by resistance to motion. That means frictional force is already given. We know the work done by force is force into displacement. Force into displacement. And change in GPE is mgh, and change in kinetic energy is half m v squared, or work done by driving force is equal to frictional force is 50 Newton. 50 Newton and displacement is 12 meter. It traveled a distance of 12 meters. Mass of particle is 25 kg. The box is 25 kg and acceleration due to gravity is 10, and then height. Height is, already we have found 12 sine 8 degree. 12 sine, then plus half means 0.5. Mass of the particle is 25, then v square. Now look at this. The particle started at the speed, initial speed was 0 and the final speed was 2.4. So it is 2.4 square. V square means we know the difference between the initial and final velocity. So it was started from rest. Okay, it was started from rest and final velocity was 2.4. So we will write 2.4 square minus 0 square, which is unnecessary to be written. Then if we simplify, it is work done by driving force is equal to 600 is on the left side, so it is going to be positive, plus 250, that means 3000 sine 8. 3000 sine 8 is equal to, let it remain unchanged, 3000 sine 8 degree. Then if we calculate this, it is going to 12.5 into 2.4 square, that is 72. It is 72. Hence our work done by driving force is going to be, if we calculate all of this, then it is going to be, after rounding up to three significant figures, it is going to be 1090 joule. That is what the answer to this question. The next question has been chosen from the same paper 9709/45 for the session May June 25, and we are solving question number 7. It says two particles A and B of mass 6.5 kg and mkg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope which is at an angle of alpha to the horizontal ground, where tan alpha is 5 over 12. A is on the rough slope and B hangs below the pulley. The coefficient of friction between the slope and A is zero point 0.4. Given that the system is in equilibrium, find the set of possible values of M. Actually, this belongs to different question. I mean different topics. So we are going to solve question number B. Question number B says it is given that M is equal to 12 and the particles are released from rest with the string taut. Use an energy method to find the speed of the particle when each particle has moved 0.6 meter. You may assume that this occurs before A reaches the pulley or B reaches the ground. So that is what our question. We will have to, as both the questions are interconnected with the same diagram, so we will have to extract some information from the previous one. So let us write from A. First of all, we should know sine alpha. Sine alpha is equal to 5 over 13. 5 over 13. Then normal reaction force was 60 Newton. 60 Newton, and mu is given 0.4. Mu is the frictional coefficient between the rough surface and the object is mu is equal to 0.4. So these are the information we can extract from the previous solution. How is it sin alpha is equal to 5 over 13? Let me show you. Suppose this is a triangle, okay, and here it is written that tan alpha is equal to 12 over 13. That means 12 over adjacent is 13. If vertical line or perpendicular line is 12, so surely it is going to be, sorry, it was tan alpha. Tan alpha was actually 5 over 12. So 5 over 12. So definitely hypotenuse is 13. So it is going to be 5 square plus 13 square must be, Pythagoras theorem. Hence our sin alpha is, that means adjacent over, perpendicular over hypotenuse. Okay, so sin alpha is 13. Now the other component, that is height. Let us go back to the diagram. Here it is written, they have told that A was moving downward. Sorry, B was moving downward. B is moving downward. So height of B will be negative. If B moves downward, A must move up. Okay, because their direction is opposite to each other. So B is moving downward and A is moving up. For A, velocity, I mean height is going to be positive, final height. For B, final height will be negative. So let us find the heights. So B is just moving downward, hence HB height of B, it is moving downward, simply zero point 0.6 meter, 0.6 meter. But what about the particle A? Height of particle A will be, it is on the sliding the inclined plane, so it is not vertical height. Remember, for B is moving downward, vertically downward, but A is not moving vertically upward, it is sliding up an inclined plane. So it is to be analyzed, HA is equal to zero point 0.6 sine alpha, and sine alpha we have already written that sine alpha is 5 over 13. 5 over 13. That means it is going to be 3 over 13. Height of particle A is, final height is 3 over 13. Well, now we can start our solution, as we do have all of the components. So let us write work done by driving force minus work done by resistance to motion is equal to change in GPE plus change in KE, kinetic energy. Now, driving force, actually there is no driving force because the particles were released from rest. So driving force is 0. Now, work done by resistance to motion, as there is a frictional force, so we know the work done by resistance to motion is force into displacement is equal to change in GPE is mgh, and change in kinetic energy is half mv squared, or frictional force is mu r. Our mu is zero point 0.4 and normal reaction is 60. So it is negative 60 into zero point 0.4. Then displacement was, it traveled 0.6 meter. So zero point 0.6 equal to mass of the particle was, since there are two particles, so we will have to find the potential energy, change in potential energy of each of the particles, as well as change in kinetic energy of each of the particles. So mass of particle P is, particle P was 6.5. 6.5. Mass of particle A was 6.5 kg. So let us write 6.5 kg into acceleration due to gravity is 10. And height for A, look at this, it is negative. Okay. For A it was positive. Sorry. For A it is positive and height was 3 over 13. 3 over 13. Plus mass of particle B is given, it is 12. So 12 into acceleration due to gravity is 10, and height is negative. So it should be, because B was moving down, that's why the symbol should be, symbol in front of this is negative. Negative, and height was 0.6 meters. 0.6 plus. Now change in kinetic energy, half of mass of particle P was 6.5, I mean particle A, and final velocity was to be obtained. So v square initial velocity was 0 because the particles were released from rest, plus zero point 0.5, and mass of particle B is 12 kg, 12, and initial velocity was 0, final velocity is to be obtained, which is v squared. Then if we simplify more, it is going to be minus 14.4 is equal to, that is going to be 65.5. So 15 minus 72, 15 minus 72 plus, this is going to be zero point 0.5 into 0.65 plus zero point 0.5 into, I mean 6 into 0.65 into this, that is 9.25. 9.25 v squared, or our 9.25 v square is equal to, or 9.25 v square, if we simplify this, it is going to be 42.6. 42.6. Hence our v is going to be square root over 42.6, 42.6 over 9.25, and if we round it up to three significant figures, it is going to be 42.6 over 9.25, that is 2.15, 2.15 meter per second. So that's all about this, and that has been the final solution under the same topic. And I tried my level best to explain every tiny part. It is work energy equation. In work energy equation, the components are height as well as velocity. So height means difference between final and initial heights, and velocity is also difference between the final and initial velocities.